And you're live.
All right. Welcome, everyone. I'm Christopher Speller, core developer at Mattermost here. I'm going to do a quick talk on performance. Just the outline here. The only thing I want to mention here is some of the features I'm going to be talking about are enterprise features. So instead of mentioning it all, I just put this on every slide that's an enterprise feature. So if you see the symbol to use it, you have to be an enterprise. You have to have bought an enterprise. All right, so I'm going to start with some developer tools. Probably the most useful developer tool to find performance issues in Mattermost is the Golang PF Tools. It's an amazing tool set that we have built into the Mattermost settings. So you can just, you can see here, I took a little excerpt of the Mattermost settings config.json. All you have to do is enable metrics, and the PF tools will become available to you as well. I'll get to metrics later, but for now, the PF tools provide three fun things. There's the CPU profiler, which is pretty much what you expect from any other languages profiling tools. Obviously useful. There's the Go routine profiler, which Go routines in Go, if you're not familiar with it, they're analogous to threads in other languages, except for they're extremely lightweight, and we run a whole bunch of them. So dumping a Go routine profile is incredibly helpful for debugging performance issues because it tells us what the application is doing currently. The third type is block profiling, which gives you some information about where Go routines are blocked, whether they're waiting on. Helpful if you're trying to debug race conditions and resource starvation issues. There's not a lot of good documentation on it, but there's a blog post profiling Go programs. These slides will be available for these links afterwards. If you want to know more about these tools, go there. So the next thing I want to talk about is we have a metrics feature in Mattermost and an enterprise edition, but if you do have it, it's extremely useful for identifying performance issues. We use it all the time when we're working to improve the performance of Mattermost. I just want to highlight a couple of the sort of more interesting ones you might want to look at. So the number of Go routines is probably the thing I look at the most, because if Mattermost has gotten into a state where it can't keep up, you'll see the Go routine numbers start to climb. Then everything else will go wrong. So a good first indicator of something going wrong with the Mattermost server is the number of Go routines. Normally, it should say approximately double the number of connected WebSockets. So if you have 5,000 users connected, and like their WebSockets are active, you should have 10,000 Go routines. Some more interesting stuff is the number of database connections. So if you're having database issues, you'll see this spike up before problems are happening. API errors and requests. So we keep track of the number of requests going to the Mattermost server. Helpful for knowing how much machine you need, and then API errors if there's something going wrong. Message rates is sort of the same thing as requests, but it's like specific to posted messages. And then WebSocket broadcasts, which if your clients are having performance issues, is something to look at. Yeah, and I'm just going to. Actually, I'm just going to go to the next slide. So another thing we look at often when we're debugging performance issues is the MySQL slow query log. So if you suspect the performance issue you're experiencing is database, like for example, you saw spikes in the number of database connections Mattermost was using, a good next step would be to look at the slow query log. Simple steps to enable it. Then the important parameter is sort of the long query time, which is the minimum amount of time that a that the database query has to take before it'll be logged. So if you set to 5 seconds, a 4-second query won't trigger it, but a 6-second will. And just play around with that until you get a good signal to noise ratio. You can also actually set it to 0 and just capture everything if you just want to sort of know. Like, you don't think there's one specific slow one, you just think one should be optimized. And then there's the MySQL dump slow tool is sort of the basic tool to process this, get a nice summary. There are more advanced tools that you can use. Googling it's the best sort of resource for that. Another interesting thing is to look at your proxy logs. Super useful for us when we're trying to figure out which routes we should spend our time optimizing. Useful, I think, for everyone to run on their server to sort of compare to what pre-release is doing, what you might expect, so you don't see like, oh wow, okay, this route shouldn't be called, like why are all my users running the password reset route, For us, we give our instructions to set up Mattermost within Nginx. A good tool to use to process Nginx logs is this Go Access tool, which is where these came from. But there are more statistics you can get with Go Access, and it's just a generally good thing to run. Now, we are developing a load test tool for Mattermost. We've been using it internally to help debug performance issues. It's been sort of very specific, focused on various areas, like for example posting, receiving posts, the things that we want to improve the performance on. But we are also now working on making it available to everybody in sort of an easy to use tool to give you a benchmark of any Mattermost server you set up, sort of a test and a benchmark. We're hoping to get it down to sort of in the sort of easiest operation mode. It'll give you one number to be like, your score is this, and then from there you can be like, does that make sense for the hardware I'm running on? Did I set something up wrong? How many users can this setup that I have handle? This is definitely something I'll be doing another presentation on when it's ready, showing you how to use it and whatnot. But for now, just know it's coming. If you're a developer working on improving Mattermost's performance, I would suggest you take a look at the repository to see if it can be useful to you. So now I'm going to talk about just a few sort of general things you want to look out for when you're developing code for Mattermost. So one of the things is database indexes. Remember to use them. A lot of performance issues we had were solved, like when we were doing our first pass of these performance issues, was solved by just adding indexes where people just forgot to add them. So you'll see this sort of code at the top of any store, like underscore store.go file, and it'll be create indexes if not exists, and then it'll go ahead and create all the indexes. If you need a new index, just add it here. Now, you might be wondering, like, when should I use this index? An index in a database is trading write performance for read performance. So you should use it whenever you have a where clause and you're selecting by that that column. So, for example, like this is, I think, users, and we select by email all the time, like where email equals email. So we have an index for it so that you can select quickly. Also, if you sort by that, you probably want an index as well because it improves sort performance. And these two above things don't happen rarely. So as I said, indexes are trading write performance because you have to update the index. For read performance, you can read it faster. So if you don't actually read from the database like a lot, or select by that column a lot, it may not be it may not be the best to add the index because it'll hurt your write performance. The other thing is just make sure it's not the primary key because those automatically have indexes. And yeah, so I already said this, but the write performance hit is worth the read performance gain. It's hard to know in a lot of situations. It requires profiling. But again, these are general guidelines. I would say most of the time where you have either of these two, and it's not rare, you probably want an index. All right, so moving on to caching. So we've implemented an extensive caching layer between the database and the Mattermost server in direct response to performance issues that our customers have been having, our customers and users have been having. So if you look at the code, it's very, you'll see it's very rushed to get these out. Right now, the caches are all write around caches. This means that when a write comes in, it doesn't talk to the caching layer at all. It just writes and invalidates. So it'll invalidate the cache, and if you have a cluster, it'll send out a message to have all of the other app servers invalidate their caches as well. So that's how the caches currently work. In the future, we want to move to write through caches. It's a small improvement on performance, but mostly it's just for easier cache management. We'll still need the invalidation update messages across the cluster, but it should provide like a cleaner architecture than what you see now. And what you see now is this. This is an example. So this is getting all the user profiles for a channel, something that's called all the time in Mattermost. So it obviously has a cache, and this is the sort of caching format you'll see right now in Mattermost. You'll have a parameter that's allowed from cache. And if this is true, we'll try and get whatever this is from the cache. We'll log metrics so we know about cache hit rates, and then return the item. If not, we missed. If it wasn't allowed, we missed. And then you'll see down below. Below here is just the code to actually do the database read. And then you'll see profiles and whatever cache it is, add with expires in seconds, and adding it to the cache. You'll notice there's no invalidation logic here. The invalidation logic I don't show here because it is currently spread throughout the system, because anytime you because of architectural issues, anytime you have to invalidate the cache, you have to do it you can't do it in the database layer because you need to talk to the cluster. And so currently, the invalidation for the caches is up at the app layer. So every time you see a write, you'll have an invalidation, which, as you can imagine, creates a lot of invalidation, a lot of room for error. So this format will be changing soon. We're going to be refactoring this into a system where there is a layer between the application layer of Mattermost and the database layer, and hopefully we can get the caches to be pretty transparent, so we don't have bugs with things not getting invalidated, people missing invalidations, which we've had. And so next thing, you see these increment memcache hit counters. So if you go into the metrics, you can actually see the hit rates on these caches, which definitely is super useful for debugging, making sure your cache actually works. Definitely, if you're writing one of these, I would recommend setting this up so you can take a look. Also, if you have a Mattermost server and one of these is lower than you see here, it might be cause for concern, because these caches do improve performance quite substantially at high load. And that's pretty much it for performance talk. Jerome, do we have any questions?
Nope, no questions. So that's it.
All right. Thanks, guys, for your time.